So we saw that this average is a little bit more than the average of the population. And so the question is this grand average significantly different from the average of the population where we got all the samples? If you do the same, probably your average will be less or more than the average of the population. And so in this case, we are going to work on the confidence interval to show margins of error of plus or minus, meaning that we'll take this average as our simple estimate. As our estimate, what we call the simple estimate, which will estimate this average of the population. And we're going to establish margins of error to see if this will be within the margins of error. Then we will say that this is more or less the same as average of the population. So we'll use this as our point estimate. So we're going to move to the next topic, which is estimations. So the next thing we're going to discuss now is confidence interval. And here I'm going to provide some notes or the summary about confidence interval, and then we'll look at the number of questions. We'll work on some problems. So let's understand what is confidence interval. Confidence interval will be these 2 points, the lower bound and the upper bound. You can remember how we worked on the lower bound and the upper bound when we discussed about empirical rule of standard deviation, which is 68, 95, and 99.5 rule. So just remember about what we learned. And we were able to find the lower bound and the upper bound. And then we learned about the probability distribution of the sample mean. And we used the central limiting theorem. And so you can remember that when we have a number of samples and then we find their means, and if we can find mean of the means, then that mean will be the same as the mean of the population. So it may not be exactly the same. However, we will create some margins of error. And I think I mentioned about it. And so today we're going to learn what is margin of error. So if you can remember as well, when we discussed about continuous distribution or probability of continuous values or continuous distributions, we learn about the curve. So we can express that in terms of the curve and normally the normal distribution curve. And we looked at the probability in terms of interval. And so if we could get area of a certain interval, then that is a probability. So from this table here, you can actually find this area where we're going to have the height times width. And so we can find this area, which also will be a probability. As well, we can find probability of this shaded area. And if we can find that area, it is also a probability. And we can do the same for this area as well. So the middle probability, or the probability at the center, it is what we call confidence level. We're going to call it confidence level. And we're going to show what does it mean by confidence level. So this confidence level or this area at the center is by default it is 95% confidence level. But sometimes you may be given different values or different probabilities or percentage, like 90%, 98%, 92%. That will be fine. But if you are not given confidence level or probability at the center, we normally consider that as 95% confidence level as default. So in the notes here, we have confidence level. And so this area or the probability at the center is what we call confidence level. I want you to understand that. And so we need to understand this middle value, which is the average. And when you're considering mean or probability distribution of the sample means, according to the central limiting theorem, so we may find average, and that average is the same as the average of the population. But in my example, you saw that the average was not exactly the same as average of the population. And I mentioned something about margins of error. So margins of error will be the what we call allowed variation, or the area which we call it the confidence level area, which will come from which will provide us the lower bound and the upper bound that average of the population can fluctuate and still will be more or less the same as average of your sample mean. So in that case, we need to find this lower bound, and also we need to find the upper bound. And to find those bounds, we need to find the z-value, which will be negative. Remember, when we are dealing with the z-values, those values are standardized, and therefore we have average, which is 0, and standard deviation, which is 1. That's what we learned before. So in this case, we can find the z-value of the lower bound, but in this case, we are not dealing with z-value of a particular value like xi, but in this case, we are dealing with the sample means. And so we need to find this area from this point to this point, and this area we call it margins of error. So remember before, when we had z-value, we could say z-value times standard deviation, which is 1, and so we could get the distance of a value or the standard deviation of a value from 0. And so we'll say, let's say we worked on 11 and we standardized that value, and so we could say 11 is that standard deviation from the average, or from 0. So in this case, instead of using standard deviation, we're going to use standard error, because we are dealing with the probability distribution of the sample means. Remember, we collected a number of averages, and we found average of those averages, and so that is what we call the grand average. And the standard deviation of those sample averages is standard deviation divided by the square root of n, which is standard error. So without confusing you, this point here is when you find your grand average, and you think that average of the population. And so, let's see. Oh, anyways, let's continue. So, in summary, at this point is what we call point estimate, and it is the average which we found. And average of the population will be assumed that it will be within the margins of error of plus this side or minus the other side. And so we need to find these boundaries, which we call them as confidence interval. And in this case, we can see that we can find this bound or limit if we know the z value, and also we can find the value here if we know z value. But we said we saw that if we have probability, we can find z value, and if we know z value, we can find probability. So if probability here is 95%, and the 5% can be distributed equally, so we have 2.5 this area and 2.5 this area. So if probability is 2.5, we could actually find the z value. So how do we find the z value? So just put equal sign and type norms inverse, because now we have probability, and therefore we will put probability which is 0.025 or 20 or we can say 2.5%. And in this case, we can find this z here, which is minus 1.96, and you can see it is negative. But also, since this area is the same as this one, we can make this this z value positive, because it's on the right side. So it is it can be 1.96. But we can also find this one. We can find this z value here. And what we're going to do is we will use the following formula. So we will take confidence level, which is 95, plus, so we will take 100% minus this the center. So we take 100% minus, assume that this is 95%, this area is 95%, so minus 95%. And so this confidence level is 95%. And if you can do the math, so let's work on that. So let me write this formula. It is confidence level plus 1 minus confidence level, but this one will divide by 2 and divide by 2. So we are taking this side, we'll call it the area to the left side, which will be 1 minus 95, which is 5%, divided by 2. And so in this case, we will divide this by 2. So that's how this formula will read. Remember, we take 1 minus confidence level, we get 100% minus 95%, we get 5%, and it has to be shared between these two areas. And so the left area will be 1 minus confidence level divided by 2. And in this case, it will be 2.5%. That's what we found here. Now, let's do the math very quickly. So I'm going to put equal sign. And I will take 95%. This will be 95% plus, put into bracket. So I'll put 100% minus 95% into bracket, divide by 2. And so if you can enter, you will see that we have 97.5. So to get this z value, we are going to use Excel function. So I'm going to put equal sign there. And here we have 97.5%. So it is our probability. So I'm going to use norms inverse function. And I'm going to click on this probability. And that will give us this positive value, which is 1.95. I mean 1.96. So it is exactly the same as we did here, using the probability of this area, which is 2.5% and 2.5%. But always Excel will give you negative value because Excel will only find the area to the left. So you can either use this formula or you can use this approach. It will be okay. So that means now we know the z values, but we want to find this area from this middle value all the way to z value. And so that's what we call standard z times standard error. So this point here is what we call point estimate. It is point estimate because we are using average of the sample averages which we have, which we got, or we look at the distribution of the sample means. And so the average, which we know that is the same as the average of the population. So we use that average to estimate average of the population. That's why we call it point estimate. So that average will be this point here, and we call it point estimate. So to get this area, we're going to use the point estimate minus z times margins of error. So I'm going to say z times margins of error. So we need to know what is margins. Sorry, z times standard error. Sorry about that. Z times standard. And so let me highlight this. So z times standard is what we call margins of error. Z times the standard error is what we call margins of error. So how do we get margins of error, or how do we get standard error? So standard error can be found as standard deviation of population divided by the square root of n, or the sample size. So that will be square root of n. That's how we can find standard error. And so we'll take standard error times z, and that will give us the margins of error. Now here you can see we have z, which is 1.96. This z here. And here we have also minus 1.96. And so what we're going to do is we'll take this point estimate, sorry about that, we'll take the z value times standard error, so we'll get margins of error of plus and minus. So let me go back here. So in this case, we have already define or understand what is confidence level, which is the probability at the middle, and point estimate is the average of the sample means, which will be our point estimate. We're going to use it to estimate the average of a population. We know how to find the z-score. We found z-score by using probabilities or the percentages that we have. Either we can use 2.5% and 2.5%. And always Excel will give you minus. But when we use this formula here, then that one will help us to find this z here. It is area at the middle plus this area to the left. So it gives us this z value, and will be the same, but this side will be positive. So we can understand this if we work on some examples. So let's go to confidence interval examples. So here we have this question. Let me make it a little bigger. So we have this problem which says, suppose scores on exams in statistics are normally distributed with an unknown population mean, but standard deviation of a population is provided, which is 3. A random sample of 36 scores is taken and has a sample mean of 68. So we know that this 68 is actually the average. Is more or less the same as average of population or the unknown population. However, we need to provide margins of error. And so we need to understand confidence level. So 90% is our confidence level. And so we are asked to find a 90% confidence interval for the mean exam score. So let's summarize information that we have. So we have no idea about the mean of population. This one is unknown. It is unknown. But we have standard deviation of population, and standard deviation of population is given, and in this case it is 3. And then we have n, which is the sample size, which is 36. And we know our sample mean is 68. And this sample mean, remember, these are the means that we select from the population. And so we use that sample mean to infer the mean of the population. So the sample mean given here is 68 points. So we are supposed to find a 90% confidence interval for the mean exam score. So formula, confidence interval equals to point estimate plus or minus z times standard deviation divided by the square root of n. So this is the formula to find confidence interval. Let me highlight it. So we have plus or minus, because minus will give us the lower bound and plus will give us the upper bound. And so we get the interval. So our point estimate is this simple mean. So let me put this way. So simple mean is actually our point estimate. We're going to use this simple mean to estimate mean of a population. So we need to find a z value. So let me write there z score. We can call z score or z value, and we will find this z value given, let me remove this. So let me just put it here, z score, and this z score will be found when we know the probability. So let me go here and write confidence level, which is 90%. And to get the z value, so we are going to apply the formula for now, but I'll show you also another approach, the other approach. So to get the z score, we're going to use confidence level plus 1 minus confidence level, but this one has to be divided by 2. Remember, we are dealing with two sides or two tails. So one tail will be divided by 2, will give one tail on one side and the other tail on the right side. So the left side and right side. So here we know that I'm going to put equal sign, and confidence level is 90, and 90 plus into bracket 100% minus the confidence level which is given, and in this case is 90%, close the bracket, divide by 2. So if you can enter, you'll see that we have 95%, and so we're going to find the z-score of this probability. So the z-score will be equal, and then norms inverse. And so we need to put that probability, and if you can click and close the bracket, we have 1.64485. That is the z-score. So let me do this. So you can find z-score as 1.64. And that z-score is, let me show you. Okay, it is this one here, the z-score. Okay. Since we have z-score, which is 1.64485, we need to find standard error, and standard error is standard deviation divided by the square root of n. So in this case, standard deviation is given. So let's put equal sign. Standard deviation of the population is 3 divided by SQRT. So select square root, and we need to find the square root of this sample, which is n. And so in this case, we have our standard error, which is 0.5. So to find margins of error, let me put it here. we're going to take z-score times the standard error. So I'll write here z times standard error. And so just put equal sign, and then the z-score is this one times standard error. So if you can enter, you will see that margins of error of plus or minus will be 0.82243. That's the margins of error. So in this case, we can find lower bound or lower interval. And also we can find upper bound or interval. So our lower bound can be found by putting equal sign, and then we're going to take this point estimate or the sample mean, which is 68 minus these margins of error, and enter. So now we have the lower bound. Let's find our upper bound. So in this case, we are going to click on the sample mean, but this time we're going to add margins of error. And so those are the lower and upper bounds. So in this case, we know that with 90% confidence level, we know that the average of, or the mean of population, which is unknown, will be between 67 and 68. It is any value between 67 and 68.8224. So if we go back to this distribution, the lower bound will be this value here and the upper bound will be here. And so our point estimate is the sample mean. And so mean of a population, which is unknown, will be any value from this point to this point. Can be any value around here. And that value, or that particular value, may be different from the value which we have as our point estimate, but variation is not significant. It is almost, we can say, more or less the same. So that's what we found here. And that's how we can actually calculate confidence interval. So let's work on the second question, which says, suppose average pizza delivery times are normally distributed with an unknown population mean. So we have no idea about the population mean, but standard deviation of a population is given. So a random sample of 28 pizza delivery restaurants is taken and has a sample mean delivery time of 36 minutes. And so we're supposed to find a 96% confidence interval. So we can do exactly the same as we say mean of population, and this one is unknown. But we can find mean of sample, which is our point estimate, and this one is given, and mean of our sample is 36 minutes. So you can say 36, and let's see the sample size. The sample size here is 28 pizza delivery restaurants, and next information here is population standard deviation. This one is 6. We can also find confidence level, which is 96%. So we have all information that we need, and therefore so we can find z value just as we did for in this section, and we're going to use that formula. So z-score or z-value can be found by using the same formula that we used above. However, we can use just the simple approach that is 100% minus 96. So I'll say put equal sign 100% minus 96%. And in this case, we have 4%. And we're going to distribute this into 2. So put equal sign, click on this particular value, divide by 2. And so we know that one side will take 2% and the other side will take another 2%. So we can find the z-score of this particular value. So let me put it here, put equal sign, type norms inverse. Remember, you can use norm.s.inverse. And so I will put this probability. Remember, probability can be in terms of percentage or decimal points. And so we're going to have negative, which is minus 2.05, whatever we get there. So we can make this absolute, and our z value will be 2.05375. That will be the z of the right side. However, we can find that z of the right side. So let me put equal sign, and remember the formula that we had. So we take 96 plus into bracket 100% minus 96, close the bracket, and this one will be we divide by 2. So we will get the probability of the of the left side or left tail. So we get 98, and with this probability we can find the z-score. So let me put that z-score here, put equal sign. So type norms inverse and click on this. And so you're going to have positive 2.5. So once we have our z-score, the next thing that we need to find is the standard error. And remember, standard error formula is a standard deviation of population divided by the square root of n, or the sample size. So I'm going to put equal sign and click on population standard deviation divided by the square root of the sample size. Close the bracket and enter. So we have our standard error. Now to get the margin of error, so margin of error, or you can call margins of error, of plus and minus. So let's find off the margin of error, and then we can find of plus or minus. So margin of error will be z-score, this z-score times standard error. And so we have margins of error. And so we can find margins of error of plus or minus if we can find lower bound, lower limit, and also we can find upper limit. So to get up a lower limit, we're going to take point estimate minus margins of error. So I'm going to click on a point estimate, which is 36, minus our margins of error, and so we get 33.67, and our upper limit will be the 36, which is the point estimate, plus margins of error, and that one will give us the upper limit. So how do we express this? So we can say that we are 96% confident that mean of population is can be between 33.67 and 38.33. So we take this one here, 38.33. So we can say we are 96% confident that mean of population can be between 33.67 and 38.33. We can say as well, we are 96% confident that mean of population can be, so we are going to use this mean of sample, which is our point estimate. So can be 36 with the margins of error of plus or minus. So we're going to look at the margins of error of plus or minus, and they are 2.05. Margins of error of plus or minus 2 point, not 2 point. So margins of error of plus or minus, which will be 2.33. Yes. So you can use these two explanations and they are okay. So one is we consider this point estimate as the mean of population, but we provide margins of error of plus or minus 2.33, meaning that we're going to take this 36 minus 2.33 and we will get this lower bound, and we're going to add and we get this upper bound. So these two explanations are correct. You can use either. So I want you to do the same for problem number 3 and problem number 4. So that will be your assignment, and I wanted to repeat exactly the same of what I did with problem 1 to problem 4. But you should follow everything that we worked on Excel in this particular topic, and then submit that in week 10. Thank you.